Hi 7th graders, this is lesson 4 session 3, which starts on page 71. For session 2 we were interpreting graphs of proportional relationships. Today all we have to do is recognize them. So here is your try it. It says Josephine uses a graph to compare the cost of renting a car at 2 different companies. Is the relationship between the cost and time proportional at either company, and how do you know? So if you remember from session 2, there are 2 things that need to be true in order for a relationship to be proportional. And I want you to take a second, look at it, think about it, pause it, write down your answer, come back to me after you've done that, because you should be trying to do this on your own. So go ahead, pause. Did you pause? I hope you paused. Okay. Now let's look at it. Okay, so you can make a table from the graph. I don't know why you'd want to, but you could. And that's got company A, which is the blue line. Let's color code it. Yay, this is the blue line. This is the pink line. And it costs at company A 0. If you rent for 0 hours, it'll cost you $0. At company B, if you rent for 0 hours, it'll cost you $8. They have a starting fee of just like the application, walk in the door, they're gonna charge you $8. Now they analyze it without doing the graph. You can skip doing the graph if you can just look at these 2 lines and think of the 2 criteria that you were given yesterday, and that is that the graph is a straight line and it passes through the origin. So let's look back up here at these. Company A's line, it is in fact a straight line. Check mark. It does in fact pass through the origin 0, 0. Double check mark, so that one is proportional. Company B, it is a straight line. There's 1 check, but it does not pass through the origin. It goes right over it. So company B does not have a proportional relationship. So remember, those are the 2 criteria for a proportional relationship: straight line and passes through the origin. Because if you don't rent the car for any hours, you rent the car for 0 hours, you should probably be paying $0. So company B, no. Get out of here. Alright, let's look at what it wants us to explain about these now. Is the relationship between the cost and time proportional at either company? Explain. Well, we determined that it was for company A, right? So yes, for company A, because their line passes through the origin, which is 0, 0, 0. There we go. How are the graphs? How are the graphs representing company A and company B alike and different? Well, if you need to look at them again, go look at them again. Ta-da! There they are. Well, they're both lines. They're both straight lines. But only company A passes through the origin. What else can we say about them? Which one is steeper? I forget already. Which one's steeper? Company A has a steeper line. I lost myself. There it is. And company A line is steeper. Has a greater slope, I should say, but we'll get to that later. Number 3, the graph for company B does not pass through the origin. Dun dun dun. Why does that show the relationship between time and cost is not proportional? Let's see, how can we word that? If it does not pass through the origin, there is no unit rate. There's no cost per mile because it's going to change because it's got that starting amount of $8. So that starting amount of $8, mess with it. And remember, another term for unit rate that we're using interchangeably is constant of proportionality. So that would be fine to put there as well. Number 4, the graph at the right. Oh, we're on to a different problem here, a different scenario. The graph at the right shows the relationship between cost and time at company C. How are the graphs for company A and C? Oh, same scenario. I was wrong. How are the graphs for company A and company C alike and different? Okay, well, I think you can probably see already. It's not a straight line. It's got a little kink in it. They've got a little discount code. Rent for this many hours and get a little discount. Just enter the coupon code CARS. Okay, but they both pass through the origin. So, company C does not have a straight line, but they both pass through the origin, which, if you recall, is 0, 0. I'm going to keep writing that because I want you to remember it forever and make 8th grade a lot easier if you remember that. Number 5, is the relationship between time and cost proportional in company C? Explain it. Nope. Let's see, how do we explain that? It's not a straight line. Can we just put that? Let's think about it. It's not a straight line. So the ratio between the points won't always be equivalent. And what I mean by that is this point here and this point here are not going to be an equivalent fraction. So let's see, this is 2, 8, 2, 8, and 3, what is this? That's 10. 3, 10. Those are not equivalent. Those are not equivalent fractions, so it can't be proportional. Okay. Number 6, the graph of a proportional relationship will always be a straight line that passes through the origin. Why? Okay. Well, the ratios on a line all have to be equivalent for the relationship to be proportional. And if it's a crooked line or if it doesn't go through the origin, then they're not equivalent. Okay, number 7 is for you to do. Think of all the models and strategies we discussed today and what, if anything, on any of these problems, on any of these pages, what here helped you understand how you could have done this try it up here. So, pause and answer that, and then unpause. Okay. So you've answered it. Now we're going to do these 3 practice problems together, and then you've got your green pages. So, number 8 here. What page are we on? 74. Number 8. 6 people ride a bus to get to work. The table shows their travel times in distances. Let's make a graph to represent this situation. Okay. So you can decide, do you want the time to be at the bottom or the distance? I'm going to go with the distance at the bottom. So this is miles, and this is minutes. And since distance has half miles in it, I'm going to make every other space a mile. So this is a half, this is a whole mile, this is 1.5, there's 2, 2.5, 3, 3.5, 4, 4.5, 5, and then for the time, let's see, what spacing do I want to use for the time? I don't want to do, because there's all the way up to 32, so I'm not going to do by ones. I'm going to do 5, 10, 15, 20, and I'm just going to eyeball it close to it. 25, 30, 35, 40. There we go. Okay, so this first traveler, their commute time is 12 minutes and they go 1.5 miles. So there's that guy. Let's see. 1.5 miles in 12 minutes. It's a little more than 10. So just gonna eyeball that there. Okay, let's make it rainbow. Okay, this person is going 2 miles and it's taking them 16 minutes. 16 minutes is 15, so this is just right above there. This third person is going to go 3 miles and it's going to take them 26 minutes. So there's 20, 25, 26. Not very visible, but gotta do what you gotta do for the rainbow. We've got 2.5 miles and they're going to take 20 minutes, so 2.5 and 20. This person is going to go 0.5 mile and it's going to take them just 4 minutes. And then my purple person is going to go 3.5 miles and that's going to take them 32 minutes. So there's 30 and there's 32. Now you might need a straight edge for this one because I think that it is so, look how close this is. You know what, I'm gonna get my straight line tool. Start at the origin and it's gonna go up this way. But look, if I get it going straight through there, it's not gonna hit the top two. So I can only go this far and then I need to draw another line. So there's a very slight bend right there. And if there's a slight bend, it's not proportional. No bends allowed. So, is the relationship proportional? No. There's a bend in it. Okay. So, you gotta be kind of precise sometimes, because that's really close to straight. And it's only because I used my line tool that I was able to see that wasn't straight. Number 9, how can you describe the relationship between x and y that each line represents? Okay, let's look at each of these. Line A represents a proportional relationship and line B represents a non-proportional. Well, okay, let's see. Are they proportional or not, for heaven's sakes? They both start at the origin. They are both straight. So, no, B is proportional. Line A represents proportional and line B represents non-proportional. Doesn't that say the exact same thing? Am I crazy? Does that say the exact same thing right there? Yeah, it does. Line number C, or C, option C, line A and B both represent proportional relationships. Okay, yeah, we figured that out. D says they both represent non-proportional. No, they're both proportional. Goodness sakes. They go through the origin and they are a straight line. Number 10, Naomi says that the graph represents a proportional relationship because it is a straight line. Is Naomi correct? And why is she not correct? Because we know she's not correct, because look at this. We already know better. We've gone over this a million times. Come on, Naomi. That's not the origin. The origin's over here. It missed. No good. Naomi is wrong because the line does not go through the origin, which is 0, 0. Okie dokie. That's all she wrote. Good luck.